If all rolls horizontally off a table is shown, where will it land on the floor? So what I'm really looking for here is that horizontal distance away from the edge of the table, or something that we call the range. To begin with on this problem, I'm going to start with a list of givens. And in fact, in this case, because it's projectile motion, it's going to be two lists of kinematics givens. One of all the vectors going in the up and down direction, and one with all the vectors going in the horizontal direction, or the left and right direction. So vertically, I know that it's not going up and not going down when it leaves the table because it says it's rolling horizontally, or has an arrow showing that as well. So that's going to be equal to 0. I know that it's going to fall 1.3 meters down to the floor. So where I start, I'll call that x naught equal to 0. And so it's going to go downwards. I'll make downwards the negative direction. And acceleration, I'll make that negative 9.8. Now, if you look at this, everything in the vertical column is negative, which means I can take everything in the vertical column and multiply it by -1 and turn everything into positive numbers. And in my equations, use positive numbers. That would work fine. It's equally correct. All you're doing is changing what you assume to be the positive direction, which would be down. Horizontally. So horizontally, I know the initial speed is 2 meters per second. That's going, in the left and right direction. Horizontally, I know the acceleration is equal to 0. That means the final velocity is 2 meters per second. And those last two numbers, the final velocity and acceleration, really don't help me out a whole lot. My paper looks something like this, pretty simple, just a little chart, nothing too fancy, not like what I just put over there on the computer. So my strategy, I'm going to find the time in the air using the vertical givens, and then because it's time, it'll go into both my columns, vertical and horizontal, and that'll give me what I need to use my horizontal givens to calculate the range. So I'm going to find the time with the vertical givens. That's going to be that x naught is equal to, x equals x naught plus v naught t plus 1f at squared. So I'll put in my numbers, and you can see I got 0 for x naught, 0 for v naught in the vertical direction. Remember, all these numbers only come from the vertical column. You can't cross columns. And then I'll reduce this with some math, simplify it. 1.3 equals 1 half 9.8 times t squared. And a little more math, and I finally get down to t equals 0.54398, and some other decimals I kept on my calculator. All right, let's find the range. So to find the range, I'm going to use the horizontal givens. So remember, the time is a scalar, so you can see I just put it into both columns because it's a scalar, it doesn't have direction, so it does go in both columns. So I'm going to find the range with the horizontal givens. X equals x naught plus v naught t plus 1f at squared, and x naught is equal to 0, a is equal to 0 horizontally. So this turns into x is equal to vx naught times t. Sometimes we just call this the range equation, something really simple, or distance equals rate times time even. Okay, let's put in our numbers from the horizontal column. So x is equal to 2 meters per second times the time I just calculated, and I kept more decimals on my calculator than what I'm showing. And that gave me x is equal to 1.09 meters with 3 sig figs.